In this video, we'll discuss Lami's theorem and free body diagram. Now, what is Lami's theorem? If three coplanar concurrent forces act on a body and keep the body in equilibrium, then each force is proportional to sine of the angle between the other two forces. In the figure, uh, F1, F2, and F3 are the three forces acting simultaneously at point O. The angle between the forces are alpha, beta, and gamma. And according to Lami's theorem, F1 upon sine alpha equal to F2 upon sine beta equal to F3 upon sine gamma. A proof of Lami's theorem. Now, if we represent the two forces F1 and F2 by the two sides OA and OC of parallelogram OABC, then the third force F3 will be represented by the diagonal OB. Now, the diagonal OB should be equal to F3 in magnitude and in opposite direction as of F1 and F2. Now, from the parallelogram, OA equal to OB equal OA equal to BC equal to F1, OC equal to AB equal to F2. In triangle OAB, angle AOB equal to 180 minus beta, angle ABO equal to angle BOC equal to 180 minus alpha because they are alternate interior angles. Now, from angle sum property, angle OAB is equal to 180 minus angle AOB minus angle ABO, and that if you calculate, you will get 180 minus gamma. Angle OAB equal to 180 minus gamma. Now, using sine rule in the triangle OAB, if you apply sine rule in let us say in a triangle, now what is this sine rule? Suppose this triangle ABC is there. Uh, Now this, let it be F1, let it be F2, and this is F3. Uh, this angle is alpha, this angle is beta, and this is gamma. Now, according to sine rule, F1 upon sine alpha equal to F2 upon sine beta equal to F3 upon sine gamma. This is the sine rule. F1 upon sine alpha, F2 upon sine beta, and F3 upon sine gamma. So, in triangle OAB, if we apply sine rule, then we'll get F1 upon sine angle ABO equal to F2 upon sine angle AOB equal to F3 upon sine angle OAB. Now, F1 upon sine 180 minus alpha, because angle ABO is 180 minus alpha, angle AOB is 180 minus beta, and angle OAB is 180 minus gamma. And we know that sine 180 minus alpha is sine alpha, 180 minus beta is sine beta, and 180 minus gamma is sine gamma. And therefore, F1 upon sine alpha equal to F2 upon sine beta equal to F3 upon sine gamma. So this way we can prove Lami's theorem. Now, free body diagram. What is free body diagram? Free body diagram is the diagram which shows the forces on the body free of another body. For example, you refer the The refer figure 1, refer figure 1, refer this figure, refer figure 1. Uh, a ball is kept uh, at the junction of wall and the floor. Now the ball is in contact with the floor at point B and at point A with the wall. So at these 2 points, reactions are acting, which is not visible, right? Now if you remove this ball from wall and the floor and draw the diagrams showing the forces acting on these objects when they are together. Now because the ball is in contact at point A and B, so the forces will act at A and B. So I have shown these forces F1, Fa and Fb at point A and B. Now equal and opposite forces will act on the wall and the floor at point A and B. So that's why, because the forces are opposite, so it is Fa and Fb in opposite direction. Now when they are together, these forces will balance each other and the body will be in equilibrium. So these two diagrams are said to be the free body diagram of the ball, and this is the free body diagram of the wall and the floor. So when you are when you are drawing diagrams of objects free of other objects, showing all the forces acting on on the on the objects when they are together, then this type of diagrams are said to be free body diagram. Now see figure 4, 5, 6 and see figure 3. Uh, there is a vessel. There is a vessel, and in this vessel, two balls are kept. Ball number 1 and ball number 2. The ball number 1 is in contact with the vessel at point A and B, and ball number 2 is in contact with the vessel at point D, and these two balls are in contact at point C. So you remove the balls and draw the diagrams for balls, for the two balls and the container or the vessel. Now showing the forces acting on the balls as well as in the container. So at point A, force Fa is acting in ball 1. At point B, the force Fb is acting in the ball. At point C, force Fc is acting in the ball. Whereas in ball 2, because ball 1 and 2 are in contact at point C, so a equal and opposite force will act on ball 2. So the force is Fc, but in opposite direction. And because the ball 2 is in contact with the container at point D, so a force Fd will act at point 2. Now in the container, opposite forces are acting Fa, Fb and Fd respectively at points A, B and D. So these are known as the free body diagram of container, that of ball 1 and that of ball 2. Now this completes the theory part of chapter 1, that is laws of forces. Now let us discuss the numericals. Now numerical 1. Now two forces of 100 Newton and 60 Newton act at a point. If angle between the two forces is 60°, find the magnitude and direction of the resultant. So you have to find out the resultant of two forces having magnitudes 100 Newton and 60 Newton acting at an angle 60°. Now you know that if these two forces are represented by the two sides of a parallelogram as shown in the figure, then applying using parallelogram law of forces, the resultant of two forces is given by R is equal to under root of F1 square plus F2 square plus 2 F1 F2 cos theta. Now here F1 is 100 Newton, F2 is 60 Newton and theta is 60 degree. And therefore, if you put these values in this equation, then what you will get? We'll get R is equal to under root of 100 square plus 60 square plus 2 into 100 into 60 into cos 60 degree. Now, if you calculate, you will get 140 Newton. So the resultant, the magnitude of the resultant will be 140 Newton. Now you have to calculate the direction of the resultant. For direction, we know the formula. Tan theta is F2 sin theta upon F1 plus F2 cos theta, which I have already discussed in previous videos. And that is equal to F2 is 60, theta is 60 degrees. So 60 sine 60 upon 100 plus 60 sine 100 plus 60 cos 60. Now, if you calculate, we'll get 0.4. Now, by using calculator, you can easily find out angle theta. Theta will be 21.8. So the magnitude of the resultant is 140 Newton, which is inclined at 21.8 degree with a 100 Newton force, which is shown in the figure. Example 2. The following forces act at a point: 50 Newton due north, 20 Newton northeast, 30 Newton due east, 40 Newton in the direction inclined at 30 degrees east of south, 60 Newton in a direction inclined at 60 degrees south of west. Find the resultant force. What angle does it make with the east? So this is the question. Now here you can see that number of forces are 1, 2, 3, 4, 5. So 5 forces are acting at a point. When you are getting questions like this, then what you do, you reduce all the forces into two mutually perpendicular forces. You reduce all these forces into two mutually perpendicular forces, and these mutually perpendicular forces are sigma fx and sigma fy. So these are two mutually perpendicular forces. So you reduce these 5 forces into two mutually perpendicular forces, in one in x direction and another is y direction, which will be sigma fx and sigma fy. So when you are getting more than two forces, you will apply polygon law of forces to find out the result. So we'll resolve all these 5 forces into two mutually perpendicular forces, sigma fx and sigma fy. Now what is sigma fx? Sigma fx is the algebraic sum of components of all these forces in the x direction, and sigma fy is the algebraic sum of components of all these forces on the y axis. So first you draw the directions north, south, east, and west. Then you draw these forces. 20 Newton northeast means it is acting at an angle of 45 degree. 50 Newton towards north, then 60 Newton force acting at 60 degree south of west, and uh, I think the force is 40 Newton. So this 40 Newton force acting acting 30 degree acting 30 degree east of south. This is the acting 30 degree 40 Newton force acting 30 degree east of south. Now, how to calculate the sigma fx? Now, sigma fx, this is the algebraic sum of all the forces along the x-axis. So 30 Newton is already in the x-axis. So 30 plus, if you resolve this inclined force 20 Newton, you will get a component in this direction and upward direction. So plus, that's why, because it is in the positive x direction. So the x component of 20 Newton force will be 20 cos 45 degree. Then we have another inclined force 60 Newton. The If you resolve this, you'll get a component in this direction and component in this direction. So it is The x component will be in the opposite direction. That's why it is minus 60 cos 60 degree. And for 40 degree Newton force, 40 Newton force, uh, the x component will be in this direction, and that will be 40 cos 60 degree positive. So if you take the algebraic sum, why we call this as algebraic sum? Because it has both positive and negative values. Now, if you calculate, you will get 34.14 Newton. Similarly, you find out the algebraic sum of all the forces along y-axis. So sigma Fy, that is for 20 Newton force, the y component will be positive because it is acting upward. So it is 20 sine 45 degree plus 50 Newton minus 60 sine 60 degree, because the component of 60 Newton force will be in y direction, will be downward. So that's why it is negative. And for 40 Newton force, the y component will also be downward. So that's why this is also negative. So if you calculate, we'll get minus 22.46. Once you have calculated sigma fx and sigma fy, इसके बाद आप एक फिगर ड्रॉ करेंगे. Now you draw a figure. uh, Sigma fx positive, so it will be in this direction. Sigma fy negative, so that's why the y-axis downward, the downward direction. Now you complete the parallelogram, and this diagonal will represent the resultant r. The diagonal will represent the resultant r. Now this resultant is acting at an angle alpha with the x-axis. Now we know that the resultant of two mutually perpendicular forces is given by r equal to under root of sigma fx square plus sigma fy square. Now you put the values of sigma fx and sigma fy. Now if you calculate, you will get 40.86. And the direction, that is tan alpha, is sigma fy upon sigma fx. So 22.46 upon 34.14. And if you calculate, alpha will get 33.34 degree.